Let's now take a look at question 4 from homework 4, which is the advanced donut store problem. So in this question, again, you've seen a similar question before in your previous homework. In this question, we are just going through again, using a loop statement through multiple customers. So there are 1,000 people who have raffle tickets, and each raffle ticket has 10 digits, and five customers can be awarded a prize if they meet the following conditions. And once 5 customers have already received the prize, we cannot assign any more winners. So the ticket has 10 digits, and to win the prize, these are the following conditions that need to be satisfied. So the second and third digits are odd numbers, the second last digit is greater than the last digit, and the sum of all digits is less than 40, and finally the fourth and the sixth digits are not equal to 4. And all of these conditions, so all 4 of these conditions, have to be true for the person to win the raffle. And so this part gives some examples of winning tickets, and we know that there are 1,000 customers, and each has this 10-digit raffle, this raffle ticket with 10 digits. So what we need to do is we need to write a script to find the index of prize receivers and assign it to the vector prize rs, meaning prize receivers, which is a 1×5 vector, and we need to use a break command that terminates our loop statements once all 5 receivers have been found. So what this means is that we have a 1×5 vector that contains the index of the person who has won the prize, and the index of the person who's won the prize is the row index. So if there's a winning ticket in the 5th row, that means the 5th person has won, and so that index should go into prize receivers. This going through multiple people like this is similar to the question we just did, question 3, except instead of having only 20 people to go through, we're now going through 1,000 people. So again, our iterator, when we do our loop statement, is going to be this number of people, and it'll be going through the rows of this 1,000×10 matrix. So let's copy this given code. Let's get started. The first thing I'm going to do is we need to use the break command. And so we need to know when to break, so when to stop the loop. And we need to stop the loop once we've found the 5 winning customers. So once we've already found 5 people, we don't want to continue finding more winners, because that's just going to override, or that's just going to add on elements onto prize receivers, but we only want 5. So what we're going to do is we're going to create a variable called count and initialize it as 0. And as we go through our loop statement, we're going to count how many winners there are, and then once there are 5, we're going to stop the loop statement by using break. So I'm going to start with count is equal to 0. Then I'm going to start my loop, and I'm going to use the iterator I, and it's going to go from 1 to num id, which is the number of people, since we want to test each person, meaning each row of the matrix cardinal. And so I'm going to end that, and let's start with, first I'm going to create a variable called test id, which is going to be which person I'm testing. So whose raffle ticket am I testing? And to do that, what I'm going to do is we said that the row number is that person we're testing. So the first row is the first person. So I'm going to use my iterator I to tell me what raffle ticket I'm testing. And I want to check all of the columns, since all 10 columns contain the 10 digits of the raffle ticket. So that is going to be the card that I am testing. The next thing I'm going to do is I'm going to set up a few conditions. So we know these are the 4 conditions that have to be met for a person to win the raffle. So what I'm going to do is I'm going to write out each condition. So I'm going to have condition 1, condition 2, condition 3, and condition 4. So let's take a look at what condition 1 is. The second and the third digits are odd numbers. So I'm going to use my AND operator, and then I'm going to use my rem function, and I'm going to say if test ID, which is that row vector I'm testing, that I initialized here, if the second element in this variable test ID is divided by 2, if that remainder is equal to 1, then I know this is an odd number, and the same goes for the third element. So I'm going to copy this code, and I'm going to test it for the third element instead of the second. And so what this code is telling me is if I divide the number at the second location with 2, if the remainder is 1, then it's an odd number, and same goes for the third location. And I want both of these things to be true, which is why I'm using the AND operator for both of these elements to be odd numbers. Then we want the second last digit to be greater than the last digit. So again, I'm going to go to test ID, and I want the second last digit, so end minus 1, to be greater than the last digit. So greater than end. All right, that's my second condition. My third condition is I want the sum of all the digits to be less than 40. So I'm going to use my built-in function sum, and I'm going to sum test ID, and I want that to be less than 40. And in this case, test ID, this is a 1 by 10 row vector. Let me write that out. It's a 1 by 10 row. It's a 1 by 10 row vector. So if I use my sum function, it's automatically just going, because it's a vector, it's just going to sum up all the numbers in the vector. If it was a matrix, we might have to specify if we want to sum vertically or horizontally, but because this is just a row vector, I can just use sum and then test ID, and that adds up all the numbers, all 10 numbers for that ticket, and we want that to be less than 40. Now my final condition is I want the fourth and the sixth digits to not be equal to 4. So again, I'm going to use my and operator, and we want two things to be true. So we want test ID for the fourth element to not be equal to 4. And we also want the sixth location to not be equal to 4. So I'm going to copy this code, and I'm going to say I want the sixth location to not be equal to 4. And we want both of these things to be true. So now I have my 4 condition statements. Each of these variables gives me a logical value, so either a 1 or a 0 if it is true or not. So what we know is we need all 4 of these conditions to be true for a person to be awarded the prize. So in this case, I can use an if statement to do that for me. So if condition 1 and condition 2 and condition 3 and condition 4, so if all of those things are true, and what I'm saying in this case is because these variables, so condition 1, 2, 3, and 4, these are all logical values. So I could write is equal to 1. I could write this for all of them, but my AND operator operates on logical values. So we learned that in module 1, that the AND operator operates on logical values. So if condition 1, 2, 3, and 4 are already logical values, oops, and I made a mistake here. This should be 2 ands. If these variables are already logical values, we can immediately just use the double AND operator on them. And if all of these are true, it's going to assign this whole value as true. So then if true, we want to perform the action that, so the first action we want to perform is, we know we've just found a winner. So we want to count that winner. So we're going to say count is equal now to count plus 1. So as our iterations go through, we're going to keep counting how many winners we have. So once we find a winner, we want to count that winner. The next thing we want to do is we want to assign the index of that winner, so that row index, to prize receivers or prize RS, since that is what's containing the indices of the prize winners. So we want to go prize RS. And we know this is a 1×5 vector. And what we can do is, since count is counting how many winners we have, let's say we found our first winner. Then count has a value of 1. And we want to assign the first element in prize RS to be equal to the index of that prize receiver. And count is equal to that value 1. So we can use count as our index for prize receivers. And how this works is, once we found our second winner, then count is equal to 2. So it'll say that the second element, since count is equal to 2, of prize RS is going to be equal to then that index of the person who won. Same for the third person, the fourth person, and the fifth person. And we already said that the row index is equal to the index of that prize receiver. And our iterator II is that row location. This is going through person 1 to 1000. So we're going to set prize RS count equal to II, since that is the index of the prize receiver. And then I'm going to end this if statement. So this is assigning the values to prize RS, and it's assigning the index of the prize receiver. Now we need to use our break statement. So once we've already found our 5 winners, we want to stop this loop statement. So what I'm going to do is I'm going to say if count is equal to 5, since once we found our 5 winners, we want to stop. My action, if this is true, is going to be break. And then I'm going to end that. So what this is saying is, once we've already found our 5 winners, when count is equal to 5, we're going to stop this loop statement, since all of the values in prize RS are already assigned. All right, so let's run this code. Oops, I am missing a parenthesis somewhere. Oh, here in my AND statement, I am missing a bracket here. Let's run that again. I am missing another parenthesis. Oh, I'm missing my whole rem statement here. All right, let's see, am I missing any other parentheses? No, I think I have an extra one. Let's run this again. All right, now my code runs. See, that's the tricky part sometimes when you're copying code. You might miss a little piece like I did right there. I completely missed copying this other rem portion in. All right, so let's copy this into MATLAB Grader. And I'm going to paste it into my MATLAB Grader. I'm going to run my script here. And I'm going to submit. Awesome, and I passed all my tests. All right, let's move on to the next question. Let's now take a look at question 5 from homework 4, which is finding the number of subsets. So in this question, you are given a vector called invec, which is a 1×n row vector of randomly generated numbers between 1 and 50 with no repeating elements. And n is a random number between 1 and 30. So you could have invec could be as big as a 1×30 row vector, and then it's populated with random numbers within it. And we're also given a variable called sumVal, which is the sum of 2 values within invec, and we want to see how many combinations we can make from invec that add to this sum val. But the rules of the game state that invec has integer values without repeating elements, and so if we are trying to find subsets, that means that numbers that are the same don't count towards a subset, because you don't want to add the same number with itself. So for example, in the case that here, for example, in example 4, where our sum val is equal to 10, you can get that by adding 8 and 2 together. You can also get that by adding 5 and 5 together. However, this is the only set of numbers, 8 and 2, since there are two different numbers that add to get the sum value that counts towards our subset. 5 and 5 doesn't count towards this problem because it's the same element. So we can't add the same element to itself. That would not count as a subset. And so here are some other examples. In example 2, we're trying to have the sum val of 13, and we can get that by adding 3 and 10 together, 11 and 2, or 1 and 12. So there are 3 subsets in this case, and each of those subsets are using 2 different elements within invec. All right, so let's copy the given code, and I'm going to paste it into my MATLAB editor. I have already saved my problem. And so now let's think about how we can solve this question using loop statements. So in this case, this was the same vector as in example 2. And now we want to figure out how many subsets there are within this vector that give us the value of 13. And so essentially what we want to do is we're going to start with an element. So we'll start with 3, and then we want to add 3 to each other element within the subset and see if it's equal to 13. So we want to go and add it to all the other elements in the subset. Then what would happen is we move on to 11, and then we want to add it to the other elements in the subset and see if it's equal to 13. But in all these cases, we don't want to add the number to itself. We don't want to add 11 to 11. So how might we do this using a loop? What we can do is we can actually use 2 loop statements. So let's say our first loop is going to loop through all of the elements in invec. So like we said before, let's say we're starting with 3, and then we want to add 3 to all the elements that it hasn't been added to previously, but we don't want to add it to itself. Then we want to go to 11 and add it to the other elements to see if it forms 13. Then we want to do 10, then we want to do 2, then we want to do 1, and then 12. So we want to go through all of the elements in this vector and see what other elements can be added to it to get 13. So our first loop is going to be going from 1 to n, since invec is a 1 by n vector. And then what can we do to make sure that we are not we're not adding the number to itself, and we're not adding the same combination twice. So for example, if we're starting with 3, we'll add 3 to 11 to see if that's a subset. Then we'll add 3 to 10, to 2, etc. But then in our next loop, when we move on to 11, we don't want to add 11 to 3 again, because 3, 11 adds to the same thing as 11, 3. This would give us the same number, 14. And so we don't want to count this twice. So how could we do that? What we can do is we can actually create another loop. We'll call that JJ. And this loop is going to go from II plus 1 to n. So what this means is, let's say we are on our first iteration of II, so we're looking at 3. Then our iterator JJ is going to go through, since this is the first element, it'll then go to, it'll start at 2, so it'll add 3 to 11. Then, since we're moving on to the next element, that's 3, then 4, then 5, then 6. So this II plus 1 is telling us where to start adding, from what element to start adding to 3. So now let's say we are on the second element, which is 11. We don't want to add 11 to 3 again, because like I said previously, that would give us the same subset, and we don't want to double count them. So what this iterator does is now we are on II equals 2, which means that we are starting at 3 for JJ, and we're going all the way to n, which in this case is 6. So in this case, we're going to 3 to 6. So then we're adding 11 to 10 to 2 to 1 to 12, and we're not doing 3 again. And then same for 10. This is the third element. So II is at 3 in this big loop, and then we're starting at 4 for JJ. So we add it to 2, 1, and 12. And this way, again, we're not adding it to elements that we've already previously tested. And so that's how we can structure our loop statement. We can use 2 loops. Okay, so let's start writing our code for this problem. So the first thing I'm going to do is I'm going to initialize the variable that I'm trying to find, which is numSet. And I'm going to initialize that as the value 0, since I want to find what the number of subsets are, and label that numSet. And if I don't find any, that value will be 0. And then within my loop, as I find subsets, I can add 1 to numSet each loop that I find a subset in, and that'll find my total number of subsets. So first, I'll start by initializing my number of subsets. And then what I'm going to do is, like I said, I'm going to start with my first for loop statement, which is going from which is II, and it's going from 1 to n. So this is looping through all of the elements in INVEC. And then, so let me end this, then I'm going to write out my second for loop, which is, we said was JJ, which is going to be equal to II plus 1, and it's going again to n. And so what this for loop is ensuring is that I'm not adding the same number twice, and I'm not counting the same subset twice. So like we said in our example, since 311 is the same as 11.3. And so this for loop is going to prevent me from double counting these subsets, and it's also going to prevent me from double counting the same number twice. So I'm not going to be adding 3 and 3 together when I'm checking my subsets. So that is what this second iterator is doing. And now what I want to do is I want to figure out what numbers I'm adding together. And so what I'm going to do is I want to access the elements within INVEC, and I want to add 2 of them together as I go through my loop. So I'm going to write out 2 variables, which is num1 and num2. And these are going to be the 2 numbers I'm adding together. And what numbers do I want to access? So let's take a look at this, this diagram again. So let's say I'm on my first iteration of II. So I'm at the element 1. And then I want to add 3 to 11, 10 to 1, and 12. And so that's what my inner loop is going to do. It's going to go through these numbers and add it to 3. And then after I've done that, my outer loop is going to go through, and then this is II is going to be equal to 2. And then I'm going to start at 3 and go all the way to n. So I'm here now, and then I go through all of these numbers, and then my inner loop has finished, so my outer loop goes again. But how can I access these elements? So for the first number I'm adding, I can access that by saying invec I. And so that is part of my outer loop, and so it's saying when I is equal to 1, I'm adding 3. And then for my inner loop, I can say invec is accessing the jjth element, and that would be going through starting at 2, the second, third, fourth, fifth, and sixth elements in this case. And so that is what my num1 and my num2 are going to be equal to. So here I'm going to write num1 is equal to invec I, and my num2 is invec jj. And these are the two numbers I want to add together. So I'm going to label that variable as sum test, since I'm testing to see if this sum is equal to some val. So I'm going to label it sum test, and I'm going to go num1 plus num2. And then what is my scenario? If that sum test is equal to some val, then I know I found a subset. So what I can do is I can write an if statement and say that if sum test is equal to some val, then I know I found a subset. And my action for my if statement, what that is going to be is I'm going to add 1 to num set. So I'm going to say num set is equal to num set plus 1. Since I've started out at 0, if I find a subset, I add 1, and so now I have one subset. If I go through my loop again, I find another subset, I add another 1 to that, so then I have 2 subsets, and so on throughout my loop. So I'm going to end that if statement, and that's my code for this question. Let's run it to make sure I have no errors. Let's run it again. Everything looks fine. Let's copy this code and paste it in here. I'll run my script here and submit it. And all of my tests are passed. Let's move on to the next question. Let's move on to our last question for homework 4, which is earthquake statistics. So in this problem, we have a table of values that provides us different earthquake statistics. So we are looking at these statistics over 5 years. So each row in this matrix is 1 year, or is representing data for a year. And then each column is a different, values for different statistics. So the first column is the number of foreshocks for that year. Then we have the number of main shocks for the year, the number of aftershocks for the year, the main shock magnitude for that year, and then the number of residential buildings damaged, the number of government buildings damaged, and the number of historical buildings damaged for each year. And all of this data is contained in a variable called earthquake stats, which is a 5x7 matrix, where again the rows are representing the year, and then each column is a value for a different statistic. We then have a variable called damage costs, which is the damage cost per building in thousands of dollars. So in this case, if a residential building was damaged, that would cost $10,000 per building. If a government building were damaged, that would cost $15,000 per building. And if a historical building was damaged, that would cost $20,000 per building. So again, that was what the question describes here. And now let's get into the questions. So I have saved my problem here. Let me copy the code, the given code. And it's important to note here that this 5x7 matrix here is created using these variables. So each of these are 5x1 column vectors, and they're all concatenated in the horizontal direction to create a 5x7 matrix. But then these values are cleared, so we can only access earthquake stats when we are solving this problem. So let's take a look at part A. Part A is asking us to create a variable named total quake, which is a 5x1 column vector that reports the total number of earthquakes each year. So we want the total number of foreshocks, main shocks, and aftershocks. And so if we look at our matrix for this problem, that means for year 1, we want to sum together the first to the third column. For year 2, again, we want to sum all of these values, we want to sum up these values, and again for all 5 years. And we can do this without using any for loops. We can just do this using built-in functions. So I'm going to write out my variable name, which is total quake. And I'm going to set that equal to the sum of then earthquake stats and we want to access the first to third columns for all of the rows, right? So for each year is a different row, so we want to access all of the years, and then we want to access the first to the third columns. Since we are adding up, we want to sum up the total number of earthquakes for the year. So that's the total number of foreshocks, main shocks, and aftershocks. And then what's important to note for the sum built-in function is that if we don't specify the direction, it's automatically going to assume 1 or vertically. So what would happen is if we just left our code as is, it would sum up in the column direction instead of in the row direction. But we want to sum up for each year because we want to create a 5x1 vector, a 5x1 vector. So we need to then specify when we're using our sum built-in function that we want to sum in the horizontal direction. And that's all we have to do for part A. Now let's take a look at part B, which is asking us to report the year in which the largest main shock magnitude occurred. And then if there are more than one largest magnitude, then we just assign the earliest year. For this, we can use the max built-in function. And it's important to note that it's asking us to report the year with the largest main shock magnitude. The years are reported in each row represents a year. So the index of the row represents a given year. So row 1 is year 1, row 2 is year 2, etc. So since we are looking for an index in this case, we can't just write out our variable like this. So max mag year. We can't just write this and then find the max. Since that would report what the maximum magnitude is, so it would report that value. What we need to do instead is we want to access the index, so we need to specify. We're not looking for what the actual value of the magnitude is, so I'm just using this symbol to specify that we are not interested in the actual value of the magnitude. We are just interested in the index, which is what it means when we write it in this format for when we're using our max built-in function. So in this case, we want to find what the maximum magnitude is, or the year with the maximum main shock magnitude. And so as we can see in our matrix, the main shock magnitude is the 4th column. And so we want to find the index of the row that contains the maximum magnitude. So we want to access earthquake stats. And we want to access all of the rows and the 4th column, since that's the column that contains the main shock magnitude. So that's how we would access that. And then in this case, I'm going to write out the rest of the syntax for this. for using max. So then we want to specify, we'll just put empty brackets, since if we just put two values, it'll find the max between those two values. So since we want to find the max within a vector, we use the empty brackets, and then I want to find the max within the column direction. So I'll specify the direction 1, which means vertically. And then if I run my script, I spelled earthquake wrong. There we go. So if I run this a couple times, as you can see, my max mag year is changing values, and this is the row location of the year with the largest main shock magnitude. If I took out this portion, my max mag year is now reporting what the maximum magnitude actually was, rather than the year. So that's why we were looking for an index, so that's why we have to use this syntax when we're using our max function, or our max built-in function. Okay, let's move on to part C. Part C is asking us to assign this variable a logical value of 1 if the main shock magnitude for year 4 is larger than the average main shock magnitude over all 5 years. So in this case, we're probably going to need to use an if statement, but first let's figure out what the main shock magnitude for the 4th year is and what the average main shock magnitude is over all 5 years. So let's first find the average magnitude over the 5 years. So I'm just gonna create a variable called average magnitude, and again, I'm going to use in this case, I'm going to use the mean built-in function. And as I did previously, I want to access this 4th column that contains my main shock magnitude. So I'm going to type in my earthquake stats. And again, I want to access all of the rows and the 4th column, since that contains my main shock magnitudes. And the mean is going to take the average over the 5 years. So it's going to add up. It's going to add up all of these main shock magnitudes, the value of those, and then divide by the number of rows in this case, which is 5, which is the correct operation we want to perform to find the average magnitude. And then I'm going to create a variable called year 4 mag, which is what my magnitude is in year 4. And so I'm going to access that through earthquake stats. And that is the 4th row and the 4th column, since again, my main shock magnitudes are in the 4th column, and then the 4th year would be the 4th row. So that's how I can access that. And now I want to write an if statement to see that, to assign true to my variable is year over mag, if the main shock magnitude for year 4 is larger than the average main shock magnitude. So in this case, I'm going to write if year 4 mag is greater than average mag, I'm going to assign is year 4 over mag as true. And then I'll say else is year 4 over mag is false. And I'll end my if statement. All right. So that is part C. Let's now take a look at part D. So part D is asking us to create a variable which is the average cost of total damages for all building types for all 5 years. Find the cost in thousands of dollars. You don't need to multiply damage costs by 1,000 since damage costs is already in thousands of dollars, so we don't need to multiply our final value by 1,000. So in this case, what we need to do is first we're going to need to find what the total cost is for all building types over all 5 years. And then what we need to do is we want to find what the average cost is over all 5 years. And in that case, we won't be able to just we won't be able to use the mean built-in function, because the mean built-in function, once we found the once we find like the total cost, that's just one value. So it would just divide by 1 in that case. Or then even if we found what the total cost is for each type of building and we created a 3x1 or a 1x3 vector, then using the mean function would divide by 3. So we'll actually need to calculate how many buildings there were in total and divide the total cost by the total number of buildings to find this average cost over all 5 years. So let's write the code and it'll make a bit more sense as we write it. So step 1, let's find the total cost for all 5 years. So to find the cost for each building each year, what we can do is I'll make a variable called building cost. And what I'm going to do is right now, if I look at the number of buildings, so if I access these elements, this right now is a 5x3 matrix. And I know that my damage cost variable is 10, 15, 20. This is a 1x3 matrix, or a 1x3 vector. And what I want to do is I want to multiply all of the like the number of residential buildings. I want to multiply each of these rows by 10, since that will give me that total cost per year for residential buildings. I want to multiply each of the government buildings by 15 to give me the cost for that total number of buildings for that year. And I want to multiply the number of historical buildings per year by 20 to give me that cost. And so what I can do to do that, sorry, that's damage costs. What I can do to do that is I can concatenate this vector on itself vertically 5 times. So, and perform then element-wise multiplication. So if I have 10, 15, 20, 10, 15, 20, and I have that 5 times, I can then perform element-wise multiplication, and that will multiply this value by 10, this value by 10, this value by 15, and so on. And that's how I can first find what the cost is per building type per year. So first I'm going to do that in my code. So in building costs, I'm going to take earthquake stats, and I want to access again all the rows. And in this case, I want to access the 5th to the 7th columns, since that is where the number of buildings is located. So this is the 5th column, the 6th, and then the 7th column. And I want to perform a element-wise multiplication with damage costs. And that's concatenated on itself 5 times. And it's concatenated vertically. So I'm going to copy this 5 times. And that way I can perform my element-wise multiplication. So now let's say I run this code. If I look at my building costs, This is giving me the damage costs per building type per year. So in year 1, it costs, well, this is 3,060. Multiply that by 1,000 for, since this is in thousands of dollars. This was the cost for damage in residential buildings in year 1. And then this was the cost for historical buildings in year 5. Now I want to find the total cost. So what I can do to find the total costs is I can sum up all of these elements together, and that's how much was paid in damages in total for all building types all 5 years. So I can make a variable called total cost, and I can do a sum of my building cost, and I want to sum up all of the elements, right? So I'm just going to use the colon to indicate that I want to sum up all of the elements together. So if I run this now and I look at my total cost, this is just one scalar value for that total cost. And now I want to divide the total cost by the total number of buildings to find what the average cost is over the 5 years for all building types, all 5 years. So now what I'm going to do is I'm going to find the number of damaged buildings, and I'll label that variable num damage. And what I'm going to do to find that is in our matrix right now, each of these elements provides the number of damaged buildings for that building type. So if I add up, again, all of these elements together, that will give me the total number of damaged buildings. So what I'm going to do is I'm first going to access, I'm actually going to make another variable called building damage. And first I'm going to access all of those, first I'm going to access year 1 to 5 and then rows 5 to 7. So these are the buildings I want, the number of buildings I want to access. So I'm going to write out again, like I did here, earthquake stats, all the rows, and then the 5th to the 7th column. And what this gives me is this inner matrix here, because I want to add up all of these elements together, but I need to kind of isolate this inner matrix first that contains all of the building data. And now to add that together, I'm going to use my sum built-in function. And again, I want to add up all of the elements together, so I'm going to use the colon to signify that I want to sum up all of the elements together, and that will sum up how many buildings we have in total. So now that we have the total cost for the 5 years and the total number of buildings over the 5 years, now we can find the average damage cost. So I'm going to write out my variable average damage cost, and I'm just going to divide the total cost by the number of buildings damaged. So I'll write total cost and divide that by the number of damage. Since those are both scalars, I can just divide like that. And if I run that code, I will see that my average damage is just a scalar value, and this is in thousands of dollars. Okay, let's copy paste our code into Grader and see if we passed all the tests. So let me run my script here and submit. And I've passed all my tests. All right, so that concludes the quiz or the homework for review video. I hope you found this helpful, and please stop by office hours if you have any questions on how to solve any of these problems.